Assalamualaikum warahmatullah. My name is Nurul Hanis Patricia. So I'm going to start off our group presentation by presenting the introductions of vanillin, gas chromatography, and also high performance liquid chromatography. Vanillin, or also known as 4-hydroxy-3-methoxybenzaldehyde, exists in a form of white crystalline powder with a scent and taste of vanilla. This is actually a phenolic aldehyde that contains a functional group of aldehyde, hydroxyl, and also ether. Vanillin is the most common aromatic aldehydes that widely used in flavor and fragrance industry. Its molecular formula is C8H8O3. So vanilla extracts contain about 1 to 2% of vanillin along some 60 to 100 other flavors chemical. In contrast to the vanilla extract, vanillin is a single chemical compound which can be synthesized either chemically or biologically. The synthetic of vanillin is most widely used in our industry due to its low cost. As you can see over here, the uses of vanillin can be seen in many products. For example, we can use it in flavoring, in perfumes, in foods, and also pharmaceuticals like medicine. So let's move on to gas chromatography applications and also principles. So gas chromatography is a type of chromatography that uses gas as its mobile phase. So the objective of this gas chromatography is to separate components in forms of vapor. So there are two types of gas chromatography. First is gas liquid chromatography, which use stationary phase in form of liquid, while gas solid chromatography use solid as its stationary phase. So the applications of GC is to separate airborne pollutant in order to make a performance-enhancing drugs in athletes' urine samples, separating oil spills, and also essential oils in perfume separation. Okay, so what are the principles of gas chromatography? So first of all, as you can see here, a sample will be injected in this injection port, or we call it as inlet, and then there will be a mobile phase which is in form of gas. The inlet gas will pass from these carrier gas tanks to this column. So as the sample passes through the column, they are going to be separated and going to be detected electronically by the detector over here. And then the outlet's going to be process the signals and we're going to read the outcome over here. So next we have HPLC, or the longer name is high performance liquid chromatography. So this HPLC is a type of chromatography that uses a liquid solvent as both its mobile phase and also its stationary phase. It is actually the most versatile and widely used of chromatography techniques amongst the chemists in order to separate and also determine compounds such as organic, inorganic, biological samples, synthetic, natural polymer, and also thermal biocompounds. So for these types of chromatography, we have three types. The first one is partition. It could be normal or reverse phase. We also have ion exchange high performance liquid chromatography, which have either anionics and also consists of anionic and also cationic. And also the last one is size exclusion chromatography, which is gel filtrations and also gel permutations. So the applications of the HPLC chromatography is, for example, to study in the analysis of sugars, analysis of pesticide residues, analysis of organic acid, and also analysis of compounds such as lipids, amino acids, toxins, and also vitamins. So the principles of the HPLC, HPLC will begin with, when we injected these solutes or analytes, or also we know it as the stationary phase into the injector on top of the gut column and also analytical column. So at the same time, there will also be the mobile phase will be released from the solvent reservoir over here and pass through the pump. So the separation will occur as the analyte from analytes and the mobile phase going to meet and pump it through this analytical column, and each component is going to elute from column as peak on the recorder. So the sample is going to be detected in this detector, and this detector will give a response to each component going to be displayed in a computer, and this the result will be known as the chromatogram. So in this video, we are going to discuss furthermore on our topic, which is the first one is the determinations of vanillin as a flavoring agent in a chewing gum by using gas chromatography, and also the determinations of vanillin in alcohol extract by using the high performance liquid chromatography.
Next, I'm Nurul Fatihah binti Kamar Zaman. We present about material and method. We will start with gas chromatography. First, chemical and material. We will use butyl butyrate, menthol, vanillin, methyl salicylate, eugenol standards, ethanol of liquid chromatography grade, and chewing gum. Besides, sample contamination can occur in every stage of analytical procedure because it is ubiquitous in laboratory environment. Therefore, all the glassware was truly washed and rinsed with deionized water and acetone prior to use. Standard stock solutions of butyl butyrate, menthol, vanillin, methyl salicylate, and eugenol were prepared in ethanol. Standard working solution were prepared by stock solution with serial dilution. All solutions were stored in amber vials at 4 degrees Celsius for later use. Second, the apparatus. We will use gas chromatography system GC 2010, the rotary vacuum evaporator, the CW 2000 ultrasound microwave, analytical instrument technology, RTX 1701 capillary column, the high-speed tap-top, centrifuge and high-speed universal pulverize, and lab solution workstation. Third, sample preparation. The chewing gum samples were firstly frozen at negative 20 degrees Celsius for 2 hours to facilitate crushing and crush it into small particles with universal pulverizer. Then the weighed powdered chewing gum sample 2.5 gram were added into a microwave flask containing liquid chromatography grade ethanol 50 ml with a reflux condenser, and the temperature sensed by infrared sensor was set to be 60 degrees Celsius. The mixture was irradiated with microwave power at 400 watt for 30-minute ultrasound microwave synergistic extraction. The status of the extraction was observed by a video liquid crystal monitors. After completion of synergistic extraction, the mixture was transferred to the centrifuge tubes and centrifugated for 10 minutes at 10,000 rpm. Then, the liquid supernatant of the synergistic extracted mixture was collected. All supernatants were merged and evaporated to dryness by a rotary vacuum evaporator. The final solid residue was dissolved in 2 ml liquid chromatography grade ethanol. The detection of trace targets in the sample can be guaranteed by enriching and concentrating 25 times for this target. Finally, 2 ml solution was filtered by polytetrafluoroethylene shrink filters with a pore size of 0.45 micrometer before gas chromatographic analysis. Fourth, real samples assay. First, taking gums without any volatile flavor compounds as a model. The 5 flavor agent, which is first 303 microgram of butyl butyrate, 215 microgram of ethanol, 290 microgram of methyl salicylate, 224 microgram of eugenol, and 211 microgram of vanillin. All of these were respectively added into above gums about 2.5 gram. The sample were prepared according to the above-mentioned method of sample preparation, and the determine was carried out. The recoveries and RSD were calculated in according with the result of gas chromatographic method. Subsequently, standard recovery method was also performed on the real sample assay strawberry count by the above-mentioned process. Next, we will move to HPLC chromatography. For the apparatus, we will use Beckman culture 7500 spectrophotometer, Waters HPLC instrument, and nucleosyl C18 columns. Next, reagents and solvent. Vanillin was obtained from ICN Biochemicals, also methanol, HPLC grade, and ultra pure water was obtained. Vanillin stock solution 1 mg per 1 ml was prepared in mobile phase solution and stored in an amber bottle at 4 degrees Celsius. The following mobile phases were studied, which is water ratio methanol, acidified water with phosphoric acid ratio methanol, water ratio acetonitrile, acidified water with phosphoric acid ratio acetonitrile. These mobile phases were selected due to the separation properties of the columns. Acidified water had not affected in improvement of retention time of vanillin. The shortest retention time of vanillin was found when water ratio methanol was used as a mobile phase compared to water ratio acetonitrile. Finally, the mobile phase of pure water and methanol was considered most adequate. The wavelength of 231 nanometer was determined as the most adequate for vanillin quantification because the maximum absorbance at this wavelength. Ethanolic vanilla extracts were diluted 100 to 500 times in mobile phase, and trace amount of ethanol had practically no effect on retention time, and no distribution of vanillin peak occurred. The vanillin peak was confirmed by comparison with the specified UV spectrum. No interference of the other compounds present in vanilla ethanol extract was observed, probably due to the short time of the chromatography. So that's all from me. We will go to the next part.
Hi, Assalamualaikum. I am Nurul Syahidah binti Abdul Rashid and I am in charge for the results. Part 1. Gas chromatography. Since our case study is about analysis of vanillin, hence we will discuss and analyze the vanillin compound only. From the figure 1, gas chromatogram of the mixed standard solutions. The retention time obtained for the vanillin is 9.90 nanometres, where the x-axis is the retention time moment and the y-axis is the intensity. Okay, next. Table 4. Calibration curve of the 5 analyte in the ethanol and the performance parameters. Before that, regression equation obtained for the vanillin is A equal to 4.93 times 10 to the 6 C dash 1.9 times 10 to the 5, where the A is the peak area for the target and the C is symbol for the concentration. Okay, back to the table. The slope 95% of confidence interval obtained for the vanillin is 4.93 plus minus 0.021 times 10 to the 6, and the intercept 95% of the confidence interval obtained is negative 1.9 plus minus 0.20 times 10 to the 5, while the regression coefficient obtained for the vanillin is 0.9974, and the linear range is around the 0.001 until the 1.00. And the last one is the LOD, which is the limit of the detection obtained for the vanillin is 0.09. And that is all for the result gas chromatography.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Raudah binti Muhammad Nazri. I'm from class AS1205K.
In this part, we will discuss about the presence of the vanillin peak. Vanillin is one of the most widely used flavor compound in food, beverage, pharmaceuticals, perfume, and medical industry. Various analytical techniques have been reported to identify trace amount of volatile compounds. Many conventional methods are based on chromatographic techniques such as gas chromatography, which is GC, GC coupled with mass spectrometry, GCMS, and high performance liquid chromatography, HPLC. Among them, GC and GCMS have attracted growing interest in the qualitative identification and quantitative measurement of the volatile compound. Since the content of flavor agent in chewing gum is low, the extraction and arrangement of these trace flavor agents are the crucial step before the selective and sensitive detection. Here, as an effective technique, to extract target from food sample, which is ultrasound microsynergetic extraction. It is used to extract and enrich flavor agents from chewing gum. In order to obtain the best performance of the extraction and enrichment, several extraction conditions were optimized by rationally designed orthogonal tests. The extraction temperature was set at 60 degrees Celsius, which was about 20 degrees Celsius lower than the boiling point of each solvent in order to prevent violent boiling. The obtained gas chromatogram of mixed standard solution was shown in figure 1. From the chromatogram shown above, there is a presence of vanillin with retention time of 990 minutes in the sample that has been analyzed. Thus, its retention time is approximately equal to the time required for a molecule of the mobile phase to pass through the column. Besides, carrier gas used is nitrogen gas with the flow rate 30 ml minute -1, and the stationary phase used is 0.5 microliter. For quantitative analysis, the calibration curve of vanillin shows that its concentration is around range of 0.001 to 1.00 mgml-1, which indicate good linear relationship. Linear range is the range of concentration where the signals are directly proportional to the concentration of the analyte in the sample. Besides, the limit of detection, which is LOD, for vanillin is 0.09, which is based on calibration curve slope is determined as 3st y per x divided with the slope. Meanwhile, the regression coefficient R for vanillin are 0.9974, represent that the quantitative detection of target is accurate since the value is more than 0.9900. The closer the value are to 1.00, the more accurately the curve represents the detector response. This result shows that the accuracy of the calibration curve was achieved. The equation for the regression coefficient is shown below. Y in this equation is mean of y, and x is the mean of x. Last but not least, vanillin value obtained for intercept from a graph is negative 1.9 plus minus 0.20 multiplied to the 10 power 5. Meanwhile, the vanillin value obtained for slope is 4.93 plus minus 0.021 multiplied with the 10 power 6, where the value of slope obtained using this equation. The beta show as slope of regression line. Furthermore, a 95% confidence interval for beta I has two equivalent definitions, which is the interval is the set of value for which a hypothesis test to the level of 5% cannot be rejected. The interval has the probability of 95% to contain the true value of beta I. Therefore, the above result confirms that the purpose of method ultrasound microsynergetic extraction coupled with GC were reliable and appropriate for detection of flavoring agent in chewing gum. In conclusion, the reliable detection of food additive is of significant importance to ensure food safety and concordance with regulation. In this work, a new method for the simultaneous determination of 5 flavoring agent content in chewing gum was established by
the ultrasound microwave synergistic extraction combined with GC technology. The flavor agent will effectively extract from the chewing gum sample through ultrasound microwave synergistic extraction. Furthermore, 5 flavoring agents were simultaneously identified and determined by GC technology. The statistical results demonstrate that the proposed method was efficient and practical for the determination of the flavoring agent in chewing gum and other food. Therefore, the proposed ultrasound synergistic extraction combined with GC technology would hold great promise for application in the food safety assay.
Part 2. High Performance Liquid Chromatography Results. From the table 1, we can see that they experimented on different types of column, such as RiverPhase C18, Microsoft C8, and Microsoft C18. From the result, we also can see that the elution time of the vanilla obtained is around 7 minutes until 36 minutes, and mostly of the flow rate obtained in this experiment is 1 milliliter per minute. Next, figure 1, spectrum of vanillin in water methanol solutions. Okay, from the graph, we can see that they have 4 peaks. Okay, the first one is 204 nanometer. The second one is 230.9 nanometer. And the third one is 279.3 nanometer. And the fourth one is 310.1 nanometer. And the wavelength of the maximum absorption is 230.9 nanometer. Furthermore, figure 2, a chromatogram of vanillin. From the graph, we can see that the rotation time obtained for the vanillin is 2.21 minutes at 230.9 nanometer only. And the x-axis is minute and the y-axis is area under the curve. And that is all the result for the high performance liquid chromatography HPLC. Thank you.
Hello, Assalamualaikum. I am Nurul Fatin Fahira binti Abdul Aziz from AS12005K. Now it's my turn to present my part, which is the discussion on the analysis of vanillin in the alcohol extract by the high performance liquid chromatography HPLC. So let's go. In this analysis study, the table 1 showed the summarization of the vanillin quantification from many types of the columns used, where the results obtained for their mobile phase used, flow rate, and the vanillin elution time recorded were referred by the other authors from different journals, except for the last one that only will be focused, which was the column of nucleosyl C18. As mentioned in the methodology part, column apparatus used in this study was nucleosyl C18, known as guard column type, with the column packing particle size is 5 to 10 micrometer. The function in using this guard column is to protect and increase the lifetime of analytical column by retaining debris, the pump seal fragments for example, that could affect the column to be clogged and changing its column efficiency. Also retain highly soft compound that would be caught on and not be eluted from the analytical column. According to the organic phase used as a mobile phase in this HPLC analysis, that was water and methanol with a ratio of 50 to 60 respectively. The types of HPLC applied in this study can be known, which is partition chromatography. Based on the water with methanol as the mobile phase, and it was a polar compound, while the stationary phase was non-polar, hence the chromatography was in a reverse phase, where the most polar component will appear first. Usually, the compounds present in vanilla extract are vanillin, including other important chemicals such as para-hydroxybenzyl alcohol, para-hydroxybenzoic acid, para-hydroxybenzaldehyde, and ethyl vanillin. Unfortunately, the interference of these chemicals compounds were not observed in the analysis except for the vanillin due to a short time of chromatography, where the elution time of vanillin only took 2 minutes as overall. Initially, it had practically no effect on retention time and no distortion of vanillin peak occurred, but a solid property detector was used in response to some property of solids such as ultraviolet UV absorbance that is not possessed by mobile phase. Therefore, the vanillin peak was confirmed by the comparison with its specified UV spectrum. Moreover, the vanillin diluted in a mobile phase of water methanol of 40 to 60 and acidified pH of 4.3 to 6.3 with flow rate 1 ml per minute has shown 231 nanometer as the wavelength of its maximum absorbance in figure 1. Standard solution of vanillin has dissolved in the mobile phase and the analysis run lasted 15 minutes. Last but not least, the retention time of vanillin was only 2.21 minutes and at 231 nanometer after the flow rate was 1 ml per minute and the injection volume was 20 microliter and the lowest detection limit was below 1.0.1 microgram per 20 microliter of injected sample. As conclusion, the vanillin was separated by a nucleosyl C18 column in the HPLC analysis through reverse phase in the partition chromatography. The qualitative analysis of this study was the identification of vanillin itself in the alcohol vanilla extract, while the quantitative analysis was the vanillin peak obtained that responds the height of 2.600 within 2.2 minutes with the most adequate maximum wavelength absorbance at 231 nanometer. Hence, the purpose of this study to develop a simple and rapid HPLC technique for vanillin determination in ethyl alcohol extract was successfully achieved. These are the two journals that we refer in completing this video assignment along with the list of references. So that's all from us. Thank you and bye!